So now we can bring in our volumetric pass, so I'll press R and we want to grab this RS, let's see, volumetric, and we will import this, and I will just want to merge this on top of everything for now at least. So let's preview the result, and this should be a plus operation. Now we will have to drop down a gray node from over here, and we probably have to animate these the gain and the gamma for this a little bit, just so it matches with our animation and we have a nice constant result. So this will depend for each stage of this animation. We might have to set some different keyframe values, but for now what I want to focus on is we have to create a way to sort of add some noise to this volumetric pass. So let's maybe just preview this. So we want to have another layer which is basically some fog, and we want to multiply it with this volumetric pass. So this will just add a little bit of texture for this volumetric pass and just make it a little bit more realistic. So we basically just want to add some 3D noise. And in some of my earlier courses, we use this node TX Fog to generate this fog pass. Only I found that this doesn't really work well with the case that we have here, which is that the camera is rotating. And so basically the TX Fogs generate a bunch of 3D cards that have some noise applied to them, and it sort of fakes this fog effect. But since the cards are stationary, they are not really spinning when the camera rotates. So in the course where we used this TX Fog, we had just a frontal animation of the camera, so the camera was just moving in the Z direction without any spinning. So since this is rotating, we have to find another way to generate this 3D fog. And the easiest way to do this is by just using a particle system. You could also create this fog inside of Houdini by creating a box that you turn into a volume which has density, and then you can manipulate the density with volume VOPs and you can render that. But it's a really simple setup to have inside of Nuke, and we really just need something very subtle and pretty basic. So let's see, we will need to first grab the camera from the Houdini scene. So let's head over to Houdini just for a second, and here is our camera. And the problem here is that if we just export this camera node, this is actually taking the position from this pivot node. So we will have to create a new camera, and I will just duplicate this camera instead, and I will get rid of this connection with the pivot by holding Y, and I will rename this to cam exported. So we want this camera to have exactly the same settings, but we want to go to the transform, and I will set all of these to 0. You don't really have to set all of these to 0, but just to keep things clean, I will set everything to 0, and we have to disable the constraints. Okay, so we just have this camera exported now, and we want to link the translate and the rotation values here to the world position of this camera. So we can go ahead, and I will right click this translate, and I want to go to reference scene data, and we want to reference, let's go to the OBJ, let's go to our cam1, let's go to the transforms over here, let's go to world, and we want to grab the translate. Okay, and we will do the same thing for rotate. So let's right click, reference scene data, OBJ, cam1, let's go to transforms world, and we want the rotate, and I will hit accept. So when now I place this cam export and preview it inside our viewport, we should have the exact same view as our cam1, and we do. So we can check some more frames here to prove this to ourselves, but as you can see, this cam exported has exactly the same view as our main camera. The difference here is we can see that the cam exported, if we look at the translate and rotate coordinates, we can see that these are different from this cam1. Okay, so when we export over to Nuke, in order for the camera to work properly, this needs the world rotation. So this is why we have to create this duplicate. Okay, with that being said, we can go ahead and we can go to export, and we can either export as Alembic or FBX. Either are fine, so let's just go with Alembic. Let's choose a file destination. Alright, so I have a folder here called export, and the file name will be camexport.abc. And we want to export frame range from 1 to 240, and we only want to export the camera. So let's go ahead and select only our camera, so cam exported. Let's hit accept pattern, click export, and this took barely a second. And now we can step over inside of Nuke. Let's go ahead and drop a camera node. Let's read from file and select our camera. So here is my camexport.abc, and this will be my camera. Okay, so this is perfect. Let's go ahead and first let's create a particle system, and this particle system will be based basically on a simple box. So let's drop down a box geometry over here, or rather a cube. So inside of Nuke this is called a cube, and here it is. So we just want to make this big enough so that our camera is always inside of this cube. Let's go ahead and increase the uniform scale. To begin with, maybe let's use a value of 30, and now I can also grab this handle over here. So these white dots, I can grab these and I can stretch this out, so this is very similar to how it would work in Houdini, and maybe give it some extra room here in the back as well. And we will preview this in a second, but basically we want our camera and the camera field of view here to be contained within this box. So we just need to make this basically big enough for our purpose, and no bigger than that. Okay, and maybe also increase this here a bit. And I'm just looking at the field of view of the camera, and maybe I'll just bring this back a little bit. So I think this will be fine. Let's go ahead and let's drop down a particle emitter. And I will link this emit arrow, I will make this point to our cube. So here inside by default, we can see that we are starting to create some particles. Let's maybe increase the size. So these are the particles, and they are currently emitting only from the points of this box. So over here we can see that this is emit from points, and we want to emit from B box. So now we will emit frames from a kind of the volume of the box. So this is kind of like you would turn the box in Houdini inside a volume and then scatter points throughout the whole volume. Alright, and we don't want these particles to move, so I'll just set the velocity to 0. And we can maybe start with an emission rate of maybe, let's try 50. Okay, this should be fine for now. And what we can do from here is we can select a frame, pretty much any frame. So maybe we can select frame 50, and we just want to freeze these particles as they are right now. So I can drop here a particle to geo node, and I want to use the specify frame, and I will just set this to 50. So now as I play the animation, we can see that the particles are frozen and we can move around them, and we can also maybe drop a scanline render from here, and we can point to our camera, and we can preview this by hitting tab. And here are our particles, and they are moving with the camera, and they are static, and they will by default always be facing the front of the camera. So this is perfect, and now we just have to set up some texture for the particle itself. To do this, I have prepared a special cloud texture. So let's drop down a read node, let's press R, and if you go inside your textures folder, inside the cloud folder, you will have the CLD1EXR file. So just open this up, and this will be the texture basically. So from here I can set the particle to read this cloud texture, and if we go back to the scanline, here we have it. Alright, so all we have to do here is just increase the size. So maybe let's start with a value of 10, and hopefully you can see where I'm going with this. And this is looking already pretty good. And now the way we can blend these particles basically in Nuke, this is a little bit more tricky and I think more complicated than has to be, but this texture we can drop inside a crop. So let's just make sure that we are working with this format, so with this size, before we do anything else. So this crop will usually fix a lot of problems if your particles are not behaving as they should. So this is just something to keep in mind, to always have this crop when working with particle textures. And from here I want to drop down a blend matte shader. And this shader, to work with our particles, we have to set the surface blend to modulate, and then the operation can be left to over. So now from here, if I drop down a grade node, let's have one grade node to affect the brightness of our cloud texture. So with this grade node I can drop down the gain and maybe the gamma a little bit, And if I drop down another grade node from here, I will use this to only affect the alpha. So now with this other grade node, I can maybe increase the contrast here, and now we can see that we can affect the way that these particles are blending. So we might want to overall decrease their transparency. So with this node, with this first node, we will affect the overall brightness, and with this other node, we will affect the transparency. Okay, and we can preview a few frames here. Let's maybe play a few frames and see how this looks. Okay, so it's pretty good. Maybe we need to add a little bit more particles, and maybe we can also just increase the scale overall. So let's go to particle emitter, and let's also increase the size range. So let's maybe make these have a little bit more variation in their size, and just increase their size maybe to 15. And let's take a look. Alright, and maybe just increase the emission rate to 70. So just add a little bit more particles. And now we might have to go to our grade and just increase the contrast a little bit. Let's drop down the gain for the alpha, and let's just make these darker maybe. And I think this is a little bit too many particles. Let's maybe go back to 50. Since we made them bigger, we might not need as many particles. And let's maybe set the size to 12. We will be fading out the volumetric effect as we go anyway, so we don't really care too much how it looks right at the end of the animation here. Maybe set this emission rate to 60. And we can readjust the luminance a little bit after we render this out. Okay, but this will be good for now. When we overlay it with our volumetric pass, it will look a lot better anyway. So we just really need something basic over here. So from this scanline render, let's actually just drop down a write node, and let's write out this entire sequence. So let's choose a file name. So I will place this inside a folder called fog volume, and this will be fog volume underscore hashtag for frame number. And then I'll save this just as TGA, or let's just do PNG. And let's set this data type to 16-bit. So now I can render this out. So let's render the entire frame range here and hit OK. So after we write this out, we can now import it over here, and let's import our fog volume, and this is it.